Okay, this is number 28 on page 141. Find the equation of a tangent line to the curve y equals x squared at x equals 1. Show that this line is also tangent to a circle centered at 8, 0, and find the equation of the circle. So we could actually use GeoGebra to cheat and figure out the equation of the circle, but that wouldn't be any fun. So we need to figure this out, figure out how to do this using calculus. So anyway, I put a picture here with a circle at 8, 0 and the parabola of y equals x squared and the tangent line at point of 1, so it's going to be on the parabola 1, 1. But on the circle it's going to be somewhere different. So actually on GeoGebra you can figure out what this radius is, because really that's the only thing we need to find out, and it did come out to be square root of 45 or what. Anyway, you can figure that out using GeoGebra, but we need to know how to be able to do it using calculus. So how do you do it? So the line that we're looking for, and you can just do a little bit of algebra for that, has to be at 1, 1, and it has to be tangent at that tangent to the parabola. So knowing what we know about derivatives, when we take the derivative of x squared we get 2x, and then plugging in 1 we get the slope of 2, which is right there, and then just using point slope form you can pretty easily get y equals 2x as the equation of this tangent line. So that's pretty important for doing that, because we need to really figure out what the equation of the circle is, and we do know that most of the equation of the circle is going to look like this. Really the only thing we need to do is find the radius. So we need to find out where that circle and that line are going to intersect. So now we want to find where on this circle am I going to have a derivative of 2, because we know at every point on this line you have a derivative of 2. So you have a derivative of 2 everywhere on this line. So it's going to be tangent to the circle where this line and the derivative of the circle are going to be the same. So the first thing that we need to do, is we need to take the derivative of the equation of the circle, which is actually not bad at all. The derivative of x minus 8 squared is going to be 2 times x minus 8. 1 less the power is going to be 1. The derivative of what's inside is really just going to be 1 plus 2y dy dx. And I know that the radius squared is just some number. It could be irrational, which I think it is. And anyway, the derivative is, whether it's rational or irrational, it's some real number, so the derivative is going to be 0. So now getting the derivative of this by really distributing the 2 to the x and the 8, and then dividing by, and getting it to the other side, and dividing by 2y gives us the derivative to be the dy dx is equal to, this all simplifies out to be 8 minus x over y. That's an x again, I don't know how to erase. 8 minus x over y. So we want to know when that derivative is going to be 2. Okay? Because that is where the line is going to intersect. So moving this down a little bit. I don't know if it's going to let me write down here. I hope it does. Okay, so knowing that that fraction of 8 minus x over y has to equal 2, just solving this a little bit more, we have y, just cross multiplying 2y, that's over 1, 2y equals 8 minus x. Solving for y by dividing by 2 is going to give us y is equal to 4 minus 1 half x. Well, that's one equation that we have to solve for, where that has to do with the derivative. The other one is y equals 2x minus 1, which is the equation of the line. So these are set up actually pretty nicely, where y, by substitution, y is equal to 4 minus 1 half x, and y is equal to 2x minus 1. We could just set those two things together. So we have 4 minus 1 half x is equal to 2x minus 1, adding a half to each side, and then adding 1 to each side is going to pretty much get the x alone, so you get 5 there. And I'm just going to change this to 2 plus a half is going to give us, as a mixed fraction, 5 halves, or an improper fraction, 5 halves x. So to solve for x, you just multiply by 2/5 on both sides, which actually cancels that out, but it also cancels the 5 out, so x has to equal 2. Well, I need an ordered pair here, because what I'm looking for is that point on the circle. So if I plug 2 into either one of the equations, that one's a little bit easier. Y is going to be 2 times 2, which is 4, minus 1 is going to be 3. So that's the point where the tangent line is going to hit the circle. So if we look back up to here, this point right here is the point 2, 3, and you can see actually from our GeoGebra diagram that pretty much works out. So that's the point on the circle, that's 2, 3. Well, if I know that that point is 2, 3, then I could put it into my equation for a circle and find r squared, which is really what I wanted to find here. And like I said earlier, that's really the only thing I needed to find, is that r squared. So x was 2, so just a little mental math here, and I'm looking in here. 2 minus 8 is going to be -6. -6 squared is 36. Plus y was 3, so y squared is 9, and that's going to be r squared. And so 9 and 36 is 45. So r squared is 45, which is really the value that we wanted. We wanted that r squared value. So the equation of the circle turns out to be x minus the quantity x minus 8 squared plus y squared equals 45, and that gives you the equation of the circle.